Now we come to problem 65 of your textbook. This is not a very difficult question. Anyway, what it says, two blocks of masses 400 gram and 200 gram are connected through a light string over a pulley which is free to rotate about its axis. Of course, a pulley has to rotate about its axis, nothing to talk about it. The pulley has a moment of inertia and radius 2 centimeters. As I pointed out to you earlier also, that whenever you see the pulley has a moment of inertia, etc., then it is not like the pulley you worked on in kinematics chapter, where the pulley was always said to be a light pulley. A pulley was not a part of the system, but here the pulley is a part of the system. So there is a pulley, and so let's say this is the pulley. Let's say this is the pulley, and this is the center of the pulley. Pulley has a moment of inertia. Pulley has a moment of inertia is equal to 1.6 into 10 to the power minus 4 kg meter square. Of course, it is such a small moment of inertia. It is a small pulley, almost a light pulley, and it has a radius r is equal to 2 centimeter. 2 centimeter is 2 into 10 to the power minus 2 meter. Now there are two blocks. One is 200 kg block. So this is one block, and this is, of course, the 400 kg block will go downward. That is how the question has been prepared. This is the 400 kg block. That means 0.4 kg. Not 400 kg, 400 gram. And this is a 0.2 kg block. Fine. What is the question? Find kinetic energy of the system as the 400 kg block falls through 50 centimeter, etc., etc. So, looking at the question, we know automatically we know how to attack. See, this is a heavier block, so this will go downward with an acceleration, say A. Obviously, this will go upward with an acceleration, say A. Now, this pulley has a tension T1. This pulley has a tension T1? No. It will have a different tension because it is a heavy pulley. Say this is T2. In kinematics, where the pulley was light, the two tensions were same. Now it's different. The question is, find the kinetic energy of the system when the 400 kg block has fallen through 50 centimeters. That means when it has fallen through, say, height of 0.5 meter. This is the situation. In this situation, we have to find out the kinetic energy of the system and also the speed of the block at that time. Right? So, how we start? We start from the basics. Let's say the free body diagram of the 2 kg block and free body diagram of the 4 kg block. I do not want to write it once again because you have done it so many times during your kinematics chapter. So this time, without writing the free body diagram, etc., such a story, if you look at the 400 kg block, 400 gram or 0.4 kg, it is accelerating downward. So what is its downward force? 0.4 G. So 0.4 G. I hope I don't have to write all these things once again. 0.4 G is the downward force. Upward force is T1. This is equal to downward acceleration A into its mass. Okay, mass we knew. So let us write not M. We write 0.4. We write 0.4 A. 0.4 A. Similarly, considering the free body diagram of the smaller block, it has got upward acceleration. So what is the upward force? Upward force is T2 minus what is the downward force? 0.2 G is equal to its mass 0.2 into same acceleration A. From here we get T1 is equal to 0.4 G, 0.4 G minus 0.4 A. And from here we get T2 is equal to 0.2 G, 0.2 G plus 0.2 A. So we have got two equations. From here we get, let's find what is T1 minus T2. T1 minus T2. T1 minus T2 is, if you find out from T1 minus T2 is 0.2 G from here, 0.2 G minus 0.6 A. This is one equation. Now, the net torque here, if you look at the free body diagram of the wheel, here I want to write, consider free body diagram of the wheel. Consider the body diagram of the pulley. If you consider free body diagram of the pulley, then T1 is creating a clockwise rotation and T2 will try to create an anti-clockwise rotation. This is due to T2, this is due to T1. So net torque is due to T1 minus T2. So net torque is equal to T1 minus T2, T1 minus T2 multiplied by the distance from the center, which is equal to R. This T1 minus T2R has to be equal to moment of inertia I into angular acceleration alpha. Find it, moment of inertia is given here. So this is equal to I is given as 1.6 multiplied by 10 to the power minus 4 divided, sorry, not divided by, multiplied by, okay, not do this way. Let us go T1 minus T2R is equal to I alpha. So we can write T1 minus T2 is equal to I alpha upon R. I alpha upon R. Now it will be easier to understand. I is given 1.6 multiplied by 10 to the power minus 4. Alpha, I alpha by R Now, this is I divided by R. Now, alpha is again linear acceleration A by R. Alpha is again linear acceleration A by R. Right? So, what we have here is 1.6 into 10 to the power minus 4 into A by R square. Linear acceleration A by R square. This is equal to 1.6 into 10 to the power minus 4 A. A is the linear acceleration and R is given 2 into 10 to the power minus 2, 2 into 10 to the power minus 2 whole square. If you calculate this, not very difficult, it will become 0.4A. So T1 minus T2 is 0.4A. Right? We have earlier found T1 minus T2 is 0.2G minus 0.6A. So these two are same. So 0.2G minus 0.6A is equal to 0.4A. From here we get, if you take 0.6A to the right hand side, it becomes A. A is equal to 0.2G. A equal to 0.2G. Or we can write A is equal to G upon 5. So this is one answer that they wanted. No, sorry, they have not wanted this answer. We have found the acceleration. They wanted answer, what is the velocity v here when it has already dropped by 0.5 meter? So from your very, very basic equation, you know how to find out the v square. You can use the formula v square equal to u square plus 2g 2ah. Now we go to, say, part A of the question. The velocity, this velocity v, they want us to find out. The velocity v square is equal to u square plus 2g plus 2ah plus 2a. Let's write s, because it is not falling under gravity, it is falling by the rotation 2ah. So v square is equal to, u was 0, this was 0, equal to 2. A, we have found g by 5, and h is given 0.5 meter. So it is again g by 5. So it is again equal to g by 5, because 0. So because 0. This is equal to 0.5, therefore v equal to, so velocity v is equal to 1.4 meter per second square. If you put the values of g, it is 1.3 meters per second square. Here, let me do it for you. 0.5 gets cancelled with 0.5. We have 10 here. 2 gets cancelled with 10, 5 here. So it is g by 5. That is how it comes to g by 5. And this is the value of acceleration. Now, another question was, this is the value of the speed. Part B. Sorry, this is not part A. This is actually part B. This is actually part B. Part A answer was kinetic energy. Part A, find the kinetic energy of the system. Now, this system now has 3 parts. One part is a 2 kg mass, Another part is of 200 gram mass, another part is 400 gram mass, another part is the pulley. All these three will have different kinetic energies. Now, V is 1.4 meter per second square. So obviously, tangential velocity of the pulley has to be also equal to V, because this is the pulley is drawn by the string. So we write tangential velocity of the pulley, tangential velocity of the pulley is equal to V is equal to 1.4 meter per second. And omega is equal to V by R. Omega equal to V by R is equal to 1.4 divided by R is given 2 centimeter. That means 0.02, which becomes 70 rad per second. So we have the omega value of the pulley. Once we have omega value of the pulley, what is the kinetic energy pulley of the pulley? So kinetic energy of the pulley's kinetic energy is the rotational kinetic energy, is equal to half I omega square, is equal to half I is given, moment of inertia was given here, 1.6 into 10 to the power minus 4. Moment of inertia is 1.6 into 10 to the power minus 4. So half into I is 1.6 into 10 to the power minus 4. 1.6 into 10 to the power minus 4 multiplied by omega square is 70 square. If you calculate this, you will find kinetic energy of the pulley is 0.392 joule. Now, these two hanging bodies have their kinetic energies, which are half mv square. So instead of elaborating further and further, so I would like to straight write. So total kinetic energy of the system, total kinetic energy of the system is half m. Let us take 400 kg, 400 gram mass. Half m is 0.4, and v square, its velocity was 1.4 meter per second square. So 1.4 whole square plus again half m, 200 gram mass, that means 0.2 plus its velocity was same 1.4 whole square. This is the translational kinetic energy. This is translational kinetic energy. I write this is the translational kinetic energy. This is also translational kinetic energy, plus this is the rotational kinetic energy, 0.392. This is rotational kinetic energy. If you calculate all these things, you will find this is equal to, I have done the calculation, rest assured you can also do it, 0.98 joule. So this is the answer of the part A. What is the total kinetic energy of the system? Fine. Now we go to the next question.